Well, we're back here at the Cave of Science, and we're looking at the review sheet for Unit 4 for the assessment on Wednesday. So the first question asks, you got some compounds of copper and chlorine. You got compound A, compound B, and determine the value of the ratio in each compound. Well, very simply, for this, in compound A, it's 35.9 divided by 64.1. And that comes out to be 0.56. And in compound B, it's 74.3 divided by 47.2, and that ends up being approximately 1.6. So I can focus this in a little more. There we go. Now the next question is, how does the mass ratio for compound B compare to that in compound A? Well, compound B, if you divide 0.56 into 1.6, it's approximately 3 to 1. And so if you want to do the simplest formulas for compound A, well, compound A is going to be 1, so the simplest formula is going to be 1 to 1. Metals are typically written first. So for A, it's going to be CuCl. So that's going to be compound A. And then for B, we would have, it's 3. So we have 1 copper and 3 chlorine. So CuCl. CuCl3. And that would be the simplest formula there. So nothing too difficult there. Problem number 2, we've got some compounds of iron and oxygen, and you can see compound A here, compound B here, and determine the value of the ratio of the mass of oxygen compared to the mass of iron on here. So for compound A, if you were to do that, again, it's oxygen versus iron. That's approximately 1.3. And in compound B, 55.3 divided by 28.0 is approximately 2. So we can put that in there. Oh, the next one says divide these ratios and then express your answer as improper fraction. And I'll be honest with you, you're really not going to see that on the assessment at all. But for compound A, if you would go ahead and run through this, compound A is going to be approximately 4 to 1. You need to double that, if you were to call this 1 and that 2. So to be honest with you, you're not going to be doing improper fractions, but we'll put it in here. So A is going to be 4 to 1. Again, when you start doing the ratios of in each of the two compounds. And in B, looks like B is going to be about twice as big. So B is going to be 8 to 1. And what does this fraction tell you about atoms in each of the two compounds? Well, there's our ratio there. So for compound A, it's approximately 4 to 1, and then compound B, approximately 8 to 1. And again, I wouldn't get too bent out of shape over this improper fraction because we're not going to see it in the test. What would the formulas be for A? Well, what that is saying is you've got 4 oxygen for every 1 iron. So for A, we could say is FeO4. And then for B, what would the formula of the two compounds, assuming that each compound contains 1 atom of iron? And for B, it's going to be and then I'm going to have 8 of the oxygen. And that's really all that's asking you on there. I would not, again, don't worry about this too much on the assessment because you're not going to see that. Alright, let's look at number 3. It'd be something a little more realistic. Let me see if I can push that up there that you would see on the assessment. And let me get this into view here. There we go. So let's look at number 3 here. Put this down. We got some sodium chloride known as salt. Sodium chloride is composed of the elements sodium and chlorine. Analysis of a 40-gram sample of the salt finds that the salt is composed of 15.6 grams, and that would be of sodium, and 24 grams of chlorine. Express its fractions. So let's do number 3. So sodium is 15.6 over 40.0, and then chlorine would be 24.0 all over 40.0. And if you notice on here, again, going to our significant figures, we've got 1, 2, 3, 1, 2, 3, so we'd have 3 sig figs here. And again, we need to start looking at those a little bit more as we're doing the problems. So there's the fractions, 15.6 to 40, 24.0 to 40. And it says using these ratios, calculate the percent. Well, if you go ahead and divide that out, that ends up being 39 times 100 will be 39%. This one's going to be 0.60 times 100 equals 60%. And that's all that one is asking for on there. Let's look at question number 4. A similar chemical analysis is performed on 650 gram sample of the salt isolated from some road salt. Analysis shows that this sample contains 253.5 grams of sodium and 390 grams of chlorine. Determine the percent, and again, this should be salt on here somehow. So just think of this as the salt sample. And could this salt in the sample be sodium chloride? And justify your answer. So let's look at number 4 here. We can work on this one. It works the same way. We have sodium, we have chlorine. As far as sig figs, we really have only got 2 there, so 2 sig figs is going to be in our answers. And in sodium, we have 253.5 grams, 253.5 grams out of a sample of 650. And we do the math here, that comes out to 30.39 times 100, and that comes out to 39%. Chlorine, we can do the same thing. We got 390 out of 650.0, and that comes out to be 0.60 times 100 equals 60%. Could the salt sample be sodium chloride? And that would be yes. Whoops, let's see if I can pull this up a little bit. That would be yes, because these two are the same as those two. So that's it for the worksheet. And again, I would not, that whole idea of improper fractions, you're really not going to end up seeing that. So don't worry about it too much. All right.